engineering ambassadors are talented undergraduate leaders from UNL's College of Engineering. Hey, welcome to our video about flight. My name is Marissa Raker, and I'm an architectural engineering student at the University of Nebraska.
My name is Josiah Kolar. I'm a sophomore engineering student studying mechanical engineering at the University of Nebraska-Lincoln.
Hi, my name is Gabby Leiferman. I'm a junior civil engineering major at the University of Nebraska-Lincoln on the Omaha campus.
On December 17th, 1903, the Wright brothers made history when they became the first humans to ever fly in the air by themselves. They used a really lightweight plane made out of canvas and wood in order to do this, and they were actually able to steer the plane. They were able to keep it balanced, and they were actually be able to stay in the air for quite a little bit of time. But have you ever wondered what makes airplanes actually fly? It's a kind of hard question to ask, and maybe a really hard question to come up with an answer for. But we're going to help you with that today. We're going to understand what makes airplanes fly. I want answers from you guys.
I know that when I make paper airplanes, if I throw them good enough, that they fly.
Maybe if you throw something, it'll fly, but it probably won't fly very far unless you throw it really, really hard. There's four main forces that go into making something fly. We're going to talk about each of those in detail. The first force that you need in order to fly is thrust. You have to be moving pretty fast in order to fly anywhere. You don't see a whole lot of really slow planes. A second force that's present in all types is drag. And drag is basically the friction that the air causes when it runs into the plane. We'll talk about that a little bit later. A third force that's present anywhere on the world or anywhere on most other planets is the force of gravity. Gravity is to pull you down and keep you from staying in the air. And the fourth and final force we're going to talk about is lift. If you don't have any lift pushing you up, gravity will always keep you down on the ground. First, let's start by talking about this force of thrust. Now, in order to understand thrust, we need to understand the principle of inertia. Newton's first law of motion says that objects that are at rest tend to stay at rest. And this basically is where the idea of inertia comes from. Inertia is this idea that if an object is doing something right now, it's going to want to keep doing that something in the future. So you can see on the left here, there's this big heavy boulder that's definitely not moving. And it makes sense that this boulder would be really, really hard to move. And that can be explained by inertia. This boulder is currently sitting still, and it really wants to keep sitting still. You'd have to get a really big crane or a bulldozer to move this boulder. On the right, however, we have another big snowball that's moving down the hill really fast. Now, if you stood in front of this snowball and tried to stop it, it would probably run you over, and you wouldn't probably be able to stop it. And that can also be explained by inertia. Because it's currently moving really fast down the hill, it wants to continue moving really fast down the hill. And just you holding your hand out and standing there probably isn't going to do much to try and stop it. One of the principles of inertia is that inertia is directly connected to the mass of something, kind of like how heavy it is. So since these boulders has a lot of mass, it's really, really heavy, it's going to have a lot of inertia. And the same thing with the snowball. So the heavier an object is, the harder it is to get it moving in the first place, or to stop it once it's already moving. If you've ever thought about how heavy an airplane is, it probably makes sense that it's really hard to get a heavy airplane moving. This airplane, for example, do you have any guesses how much it might weigh? This airplane weighs 735,000 pounds, way heavier than that boulder or that snowball. So you're going to need some pretty powerful forces to get an airplane moving in the first place. The Wright brothers used very light materials in order to create enough thrust to overcome inertia. And so their plane wasn't very heavy at all. They used, I said it earlier, they used canvas and wood in order to make this plane really, really light. And you've noticed, if you've ever been to an airport or maybe even been on a plane, that there aren't very many planes made of canvas or wood anymore. And the reason is, as engineers have found better and stronger materials, they found out that materials like metal and aluminum are actually a lot stronger than canvas and wood, and they're a lot less likely to catch on fire than canvas or wood, and they're also not all that much heavier for the amount of material that they can carry. So the engineers have constantly been designing lighter and stronger materials in order to make the plane weigh less, which makes it easier to fly through the air. It's also really important to have powerful propulsion. The Wright brothers didn't really have any type of propulsion on their planes. They just relied on wind and catching wind in the actual canvas of the plane. But today's planes use powerful jet engines to push themselves forward and give themselves that forward thrust that we talked about.
All right, so the next force that we're going to be talking about is drag. And drag is a result of air resistance. How many of you guys have ever stuck your arm out a car window while you're going pretty fast down the street and your arm wants to immediately go backwards? Yeah, me too. Well, this is actually air resistance acting on your arm. The air molecules in the air don't really want to be moved around too much, and those are going to be pushing back on your arms, pulling it in that backwards motion. This same phenomenon is also happening to planes that are in the air. The drag is slowing the planes down, which is not very good, usually seen as bad. However, drag can be reduced with an aerodynamic design. So what is an aerodynamic design? Essentially, it is a design that is lessening the drag or the air resistance. So what makes something aerodynamic, you might ask? Things like a sleek model, some divots, and a smooth surface are all really good examples of what makes something aerodynamic. So next, we're going to show you guys a short video to further explain aerodynamic design and how it works.
Every year, millions of dollars are spent on perfecting the aerodynamics of planes, trains, and automobiles. But has this myth stumbled upon a dirt cheap solution? Well, not so far. But thanks to a car riddled with dimples,
it looks fantastic.
yeah, Adam and Jamie have one more dirty trick to try. Remember, it's the dimples on a golf ball that cut down its drag and make it fly further. So by covering the clay with these,
That's one dimpled car. If ever there was a car that looked like a golf ball, this is it.
it might make the car more aerodynamic.
This is by far one of the stranger things we've ever built. And to my mind, actually one of the most beautiful, and not aesthetically either. I mean, to me, the beauty here is that we've taken the phrase golf ball-like effect on the car to the furthest possible point. No one can accuse us of not going far enough. Is this treatment going to translate to better fuel efficiency? I really don't think so.
Adam's got his doubts. But before they test, there's one thing to make clear.
But Adam, I hear you say, you cut out 1,082 dimples worth of clay that significantly lightened the weight of the car, and that might translate to better fuel economy. Ye of little faith. For look here, we have every dimple we've cut out of this car, and into the back. It goes. Thought of everything.
Yep, everything. But will those dimples make a dent in the fuel consumption?
9,450 grams. That's our start weight.
Well, by now you know the drill.
Main tank solenoid is on. Let's go, dimple car. Thing really is lovely.
It's better from a distance.
What's funny? This is absolutely the category of things that work only as long as we need them to work. It's just going to start slopping whole body parts off any minute now.
But despite 5 runs at 65 miles per hour, the clay catastrophe never comes. So it's over to Adam.
8,972 grams. All right. Time to do a little math.
What you got?
Okay, so the clean car without any clay on it was 26 miles per gallon and change. The clay car with no dimples was 26 miles per gallon and change. The dimpled car, 29.65 miles to the gallon. There is a golf ball like that.
I feel like eating my beret. And, I'm not gonna.
We totally didn't expect that result.
If we had to bet, and not being a betting person, I didn't, but if we had to bet, we would have both said, if anything, this would get poorer mileage. Like, we should have gotten something like the dirty car did.
That's the coolest thing ever.
To explain aerodynamic design and how it works. Now, after watching that video, who can tell me why the dimples on the car made it more aerodynamic? Well, if you said it was reducing the surface area, you're exactly right. This can also be seen using the equation force of drag is equal to 1/2 c, the constant, times this fancy looking p known as density, times the speed, also known as velocity, times the area. So essentially the dimples are reducing the surface area of the car because when air flowed over the dimples, it had little to no friction. The air in the dimples kind of rubbed the air flowing over the car less than the actual car surface itself.
The next force we have is gravity. Now we know gravity as the force that keeps us stuck to the earth. And according to Newton's second law, force equals mass times acceleration. In this case, our mass being somewhat similar to our weight, and acceleration being how fast we're speeding up. Now, like we talked about earlier, planes have a huge mass, and so therefore they have a huge force, and this force of gravity has to be overcome. Now, the force we use to overcome the force of gravity acting downwards is lift. We create this large lift force by creating a large thrust force from the plane's engines. Now, the most important part on our planes to create lift is the wings, and these wings move air across them and create this special thing called downwash. A downwash, as seen in the picture, is where the air comes up over the wing and rushes back down the other side. Now, this downwash causes an area of low pressure above the airplane wing, and you guessed it, a high pressure pocket below the wing. And when you have low pressure on top and high pressure on the bottom, that is going to lift the plane up into the air and create what we know as lift. How do we know that downwash has happened? Well, if you look at this picture here, you can see that the air has gone up and over the airplane's wings. And when it comes down in that downwash, it also pushes the clouds with it and makes a pretty cool trail. Now, these areas of high and low pressure can be explored through something called the Bernoulli Effect.
Let's take a look at an example of the Bernoulli Effect in action. I have a really light ping pong ball here and a pretty powerful hairdryer. Now, this hairdryer is going to blow a lot of air past this ping pong ball. And let's see what happens. What was happening is all that air was rushing along the ping pong ball and it was creating lift on the ping pong ball, right? That's how it was able to overcome the force of gravity. It was able to create a pocket of low pressure right above here where all this air is rushing past it and a pocket of low pressure gets formed. And obviously the ping pong ball wants to go the place where it's easiest and where there's less pressure. And so it was constantly being pushed up by the hairdryer. And that's why it was able to actually stay in line with driver, even when I started to tilt it a little bit, because it had that pocket of low pressure right above it.
I have a video here that I want to share with you. And before you watch it, I want you to guess, how long do you think the longest paper airplane ever flown? How long was that in the air? If you guessed 29.2 seconds, you are exactly right. Now later, we're going to do an activity where you make your own airplane. And your airplane, although it's not going to look like the huge airplanes we see in the sky, it's going to look like a paper airplane. Now these airplanes, keep in mind, have the same four forces acting on them: drag, lift, thrust, and gravity. The only difference here is that our thrust comes from us taking the plane and launching it into the air rather than using a super special jet engine. Let's take a look at some of the engineers that study these forces acting on airplanes. Now their goal is to reduce drag but maximize both lift and thrust. The first engineer that works on an airplane is an aerospace engineer. Now an aerospace engineer is broken up into two spots: aeronautical engineering and astronautical engineering. Aerospace engineers must determine the best shape for an airplane. In order to determine this best shape, they must predict how the air is going to move around the plane and around the wings. They use computer models and mathematical models to predict how this air is going to move and then test them themselves in a lab. Now, chemical engineers are going to study both physics and chemistry, and what they're going to do is study this crazy concept called combustion, and that is where we get the energy for our planes from, using jet fuel. And so they're going to use their studies to maximize the energy that we get from doing this process called combustion. Computer engineers design the computer programs designed for flight instruments, while electrical works on all those pieces behind the computer, like the electrical wiring. So earlier we talked about how heavy airplanes are. They are just so heavy, and the job of a materials engineer is to minimize that weight. So make sure that we are using the lightest materials possible that are also going to keep our passengers safe. Next, we have mechanical engineers, and what they do is they work on moving parts. So there's lots of moving parts in an airplane. We have the doors, we also have the wings, and we also have the to design. Engineers are always improving and always making new, safer, funner innovations in the area of flight technology. And so today we're going to take some of the processes and ideas that we learned in this video, and we're going to do our own activity. We're going to make paper airplanes. To do this activity and learn more about the engineering design process, check out our flight presentation activity video. And don't forget to subscribe to our YouTube channel and comment if you have any questions.